I'm doing videos for all the odds. So here's number 3. Again, it was another question 6 on some old AP test. The function g has derivatives of all orders, and the Maclaurin series for g is equal to this. So sometimes I like to do this just to remind myself. G of x is equal to this. Using the ratio test, they tell us what to do. Determine the interval of convergence for the Maclaurin series for g. Use the ratio test on this. So to begin, we should be doing the limit as n approaches infinity of the absolute value, so ignore the -1 to the n for now, of the n plus 1th term. So when you plug n plus 1 into 2, n plus 1, remember you've got 2n plus 2 plus 1. So that's x to the 2n plus 3. When you plug n plus 1 into 2n plus 3, you're going to get 2n plus 2 plus 3, 2n plus 5. That's the n plus 1th term, divided by the nth term. So, so I'm multiplying by the reciprocal here, 2n plus 3 over x to the 2n plus 1. Work on simplifying this before you take the limit. So when you subtract your exponents on x, you're left with x squared. There's a 2n plus 3 in the numerator and a 2n plus 5 in the denominator. Those have the same degree, or it's a tie, or informal way of saying that. So this limit at infinity would equal the absolute value of x squared. Now, x squared, this series, when we're left with x squared, converges if x squared is less than 1, by ratio test. Be careful with this. You don't want to say x squared should be between -1 and 1, because x squared is always positive, but you're squaring something. So as long as x itself stays between -1 and 1, then x squared would definitely be less than 1, right? So don't get into the trap of like square rooting a -1 and thinking you've got imaginary somewhere. This is our temporary interval of convergence. We need to test the endpoints, and you do have to show the series that you're testing. It's a good idea to simplify it. So if x equals -1, then we would have the series from 0 to infinity of, there's a -1 to the n there, then it's going to be -1 to the 2n plus 1 over 2n plus 3. You need to work on this to prove that it's alternating or not. So you have two expressions with the same base in the numerator, so you can add the exponents together to get 3n plus 1 over 2n plus 3. The question is 3n plus 1, does it alternate odd, even, or is it always odd, or is it always even? If you're not sure, plug some numbers in, starting at wherever it says. So if we start at 0, we get 1. If we plug in 1, we get 4. So odd, even. If you plug in 2, you get 7, odd. So the fact that we're going between odd, even, odd, do as many as you need to convince yourself. This is alternating. Sometimes I like to rewrite that as like, so this is the same as -1 to the n. You don't have to do that. But because this is alternating and the terms are decreasing constantly, or they're decreasing monotonically, and the terms are going to 0, we can say this series converges by the alternating series test. You should write this out on the real AP test. We have 20 of these, so I'm trying to save time here. Okay, so we are going to include the endpoint -1, and we're going to show what happens if we plug in 1, the other endpoint. So then the series goes from 0 to infinity. You have -1 to the n, which was there to begin with. 1 to the 2n plus 1 doesn't need to get written down, over 2n plus 3. Well, that's also a convergent alternating series, converges by alternating series test. So both of these endpoints are included. So the interval of convergence, I'm not sure if you really need to rewrite this or not. In my answer key, I just circled that, but interval of convergence is -1 to 1. So if we plug in x values between -1 and 1, the infinite series will give us values that are exactly equal to g of x. That's what that means. Part B, the Maclaurin series for g is evaluated at 1/2. it's an alternating series whose terms decrease in absolute value. This gives us the green light to use alternating series remainder, first neglected term, instead of relying on Lagrange. The approximation for g of 1/2 using the first two non-zero terms of the series is 17 over 120. So they used these two terms, plugged in 1/2, got 17 over 120. Show that this approximation differs from actual g of 1/2 by less than 1 over 200. All right, so they've sort of done some of the math for me, but basically what they did was this. They approximated g of 1/2 by plugging into these first two terms. I'm using the series. I don't need to do the math. They've done it for me. I'm using the first two terms shown at the top of the page. And apparently that's equal to 17 over 120. I'm not going to waste time checking it. I believe them. I want to show that the difference between the actual g of 1/2 and this 17 over 120 approximation is less than 1 over 200. Okay, so how do I do that? Well, again, I can say by the alternating series remainder, I know that what is the first neglected term? The first neglected term would be, well, they didn't plug in 1/2 to this term, so that's the first neglected term. So we would just show that, well, 1/2 to the 5th over 7 should be less than 1 over 200. Now, this is a no calculator problem. You've got to do a bit of math to prove that this is true. So 1/2 to the 5th in the numerator, it can be put in the denominator. 2 to the 5th is 32. And since you are in BC Calculus, you're expected to be able to multiply 32 times 2. If not, go old school here. Or if you need to, go old school here. Nothing wrong with that. So we get 1 over 224 is less than 1 over 200. Larger denominator means smaller fraction overall. All right, and part C, write the first three non-zero terms and the general term of the Maclaurin series for G prime. So again, I did this in problem 1. Anytime I have to write out the first however many terms and the general term for G prime or integral of G of x, I always start with G of x. So just start with G of x so you have something to look at. They already gave us these terms. It was at the top of the page. It's x over 3 minus x cubed over 5 plus x to the 5th over 7. Double check those. Yeah. And then plus dot, 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 plus. What's the general term? So just take the series they gave you and write it out. It's negative 1 to the n times x to the 2n plus 1 over 2n plus 3 plus dot, dot, dot. So here's g of x. Find g prime just means take the derivatives of those first three non-zero terms and take the derivative of the general term. So the derivative of x over 3 is 1/3. Next derivative becomes 3x squared over 5 plus 5x to the 4th over 7 plus dot, dot, dot. What are we doing here? So the general term has a negative 1 to the n. We're pulling the exponent down in front, 2n plus 1. Put it in parentheses. It's a quantity. X is now to the 2n plus 1 minus 1. We subtracted 1 from our exponent, so x is just to the 2n. And the denominator is still in place. Nothing cancels or simplifies, so we just leave it like that. And that's all we had to do for part C. All right, so that finishes up this problem. By the way, the scoring guidelines are online for all of these problems. So I know I'm only posting the odds. I do encourage you to look at the scoring guidelines for these problems as well. Sometimes it can take some searching to find them, but just start typing in some of the problems for parts A, B, or C and scoring guidelines, and you should find them. But the reason I want you to do that is because it's beneficial to see, like, what do I get points for? What do I have to write? The way I'm writing these might be slightly different than the way you're writing these. Do we all have what we need to get full points? Part of that just comes from checking those scoring guidelines too.